In this video, I will explain the basic rules for naming cyclic dienes. So if the two double bonds are inside the cycle, then the diene will be considered as a cyclic diene, and then we have to follow these rules. In cyclic dienes, numbering should always start at one of the double bonds, proceed through this double bond, and then move on toward the second double bond. The double bonds must be given the smallest set of numbers, and we can always use the SDS rule, which is start at the first double bonded carbon, drive through the first double bond, and then stop at the first carbon of the second double bond. For example, in this case here, we can choose this carbon to be number 1, and then we drive through this first double bond all the way to the second double bond. In this case, our double bonds will be given positions 1 and 5. If I go in the other way around, which is starting at this point here and then moving anti-clockwise until I reach to this double bond, the positions will be 1 and 3, which is of course a smaller set of numbers, and that's why this is going to be the correct naming, and the name will be 1,3-cyclohexadiene. Now, of course, you can always start at this point here and you will end up with the same set of numbers. In this second example, we have 3 double bonds. Again, there are multiple ways to name this compound, but only one of them will be the correct one. If I started at this point here, my double bonds will be at 1, 4, and 6. If I started at this point here, my double bond will be at 1, 3, and 6. This is a smaller set of numbers. You can try different ways, for example, starting from here and then going all the other way around to the other double bond in this direction, but this will give you again a similar set of numbers to this one. So this will be the correct name for this compound. So just to make a long story short, try the different combinations, but give your double bonds the smallest set of numbers. If your double bond is branched, then again the priority should be always to assigning the double bonds the smallest possible numbers. So even in this case here, for example, I have 2 options. I can start at this carbon here, and then this will be carbon number 2, so my double bonds will be at positions 1 and 5. The other option will be starting at this carbon here and then proceeding in an anti-clockwise way until we reach to this point. So my double bonds will be at positions 1 and 3. And this is a smaller set of numbers, and that's why this will be the correct one. Now someone might say, why don't you, for example, start numbering from here? Well, yes, if I start counting from here, this will be 1 and this will be 3. So this will assign the same number to the double bond, which is good. But the problem here is that my methyl group is now at position 3. And the second priority after giving the double bonds the smallest possible numbers is to give your branches the smallest possible numbers. So we have 2 options. We can go anti-clockwise from this one to this one, and this will give the methyl position 2, or we can go from here to here, and this will put our methyl at position 3, which is not preferred, and that's why this will be the correct answer. If moving from both directions assigns the same number to the double bonds, then choose a direction that assigns the smallest number to the first branch, which is what we used to do before. So for example, in this case here, if I started from this point here, my double bonds will be at positions 1 and 4, and my methyl will be at 6. If I started from this point here, my double bonds will be also at 1 and 4, but in this case my methyl will be at position 3. Since in both cases we are getting the same numbers for the double bonds, then my priority moves on to giving the branch the smallest possible number, and that's why I will choose this to be the correct way for naming, because this is giving the methyl group position 3, and the correct name will be 3-methyl-1,4-cyclohexadiene. So in cyclic systems, just try to give your double bonds the smallest possible numbers, and only if you ended up with the same set of numbers, then move on to the branches rule. And of course, if you ended up again with the same set of numbers, then go for alphabetical order rule. For example, let's say we were given this compound, which is very similar to this one here. And again here, if I started this to be number 1, my ethyl will be at 3, my double bond will be at 4, and my methyl will be at 6. The other option is starting from here, 1, my ethyl will be starting from here 1, and then my methyl group will be at 3, double bond will be at 4, and then the ethyl will be at 6. So in both cases we are getting the same set of numbers, which are 1, 3, 4, 6. 1, 3, 4, 6. Since we are getting the same set of numbers, then we'll move on to alphabetical order rule, and that's why the ethyl, which is written first, should be given the smallest possible number, and that's why this will be the correct way for naming this compound, and the correct name will be 3-ethyl, 6-methyl, 1,4-cyclohexadiene. So these are the priority rules for naming cyclic compounds. So first of all, your priority is your double bond. Second, if you are getting the same numbers for the double bond, your priority is to give your branches the smallest set of numbers. And your last rule is, if you are getting again the same number for the branches, move on to the alphabetical order rule, and then try to give the group which is written first according to alphabetical order the smallest set of numbers. And this summarizes the rules for naming cycles. Usually we don't ask about including geometries for cyclic dienes or trienes and so on. Thank you for listening.